Okay, hello everybody, and welcome to my very last lecture on electron configurations, part 4. So we learned a simplified model of electrons in the atom previously. And in this simplified model, the energy levels fill up sequentially from lowest to highest. So basically you would fill up like this. You fill up the first energy level, and then you fill up the second energy level, and then the third energy level, and then the fourth energy level. This is what we learned. And this simplified model, it works really well for the first 18 electrons. But the real thing that happens is not that the electrons find the lowest energy level and they fill that. What happens is they find the lowest energy orbital. So which orbital can they occupy with the least amount of energy? And unfortunately, the lowest energy orbital is not always in the lowest energy level. So sometimes, for an example, third energy level orbitals, they might have more energy than a fourth energy level orbital. Which is weird, because 3 is lower than 4, right? This is why, in my opinion, energy levels is not a great name for that first number of the electron configuration symbols, but I don't get to choose the name, I just have to teach the name. So, what really happens is like this. You have some electrons that go here. The next electrons, they do what you would think, they fill up the second energy level. It mostly goes okay, up until you try to fill this right here. The third sublevel of that third energy level. So the 3 Ds are what are up here. You have the 3 S's, the 3 P's, and the 3 D's are where they really start to mess up. Electron number 19, it wants to go into the lowest energy orbital possible. So you have to imagine that it's walking around and it wants to get into a room with the least amount of effort. Now to get to the open orbitals in the third energy level, so to get right here, what it has to do is it has to walk over 3, right? Because it has to go 1, 2, 3, so it has to walk over 3 steps. And then also it has to go up 3 flights of stairs. It's right here and it has to go up the flights of stairs to get to the top. But to get to this one right here, this fourth energy level on the bottom floor, it only has to go over 4 blocks. It doesn't actually have to go up at all. So electron 19, it chooses the least amount of energy. It's the laziest electron. It does what is the easiest for it to do. And in this particular case, it actually takes less energy to walk all the way to the fourth energy level. It takes less energy to do that than to go up the stairs. And I know that seems, this is just a metaphor. They don't really go upstairs or anything. But the energy is the same thing. So that means the electron, it goes here instead of here. So it actually fills up the 4s before it fills up the 3d. Because in order to get here to the 4s, it just has to go over 4. And that's easier than going over 3 and also up 3. Maybe that seems annoying, so I got a metaphor for you. Let's say that you are right here. You want to go to a hotel, and you're lazy, you're tired, you want to get there as fast as possible. One room is on the ground floor of a nearby skyscraper, and the other room is on a small house really far away. The skyscraper has no elevator. That's important for this metaphor. So, the easiest room to get to right here is room number 1. Normally, you're going to want to go here, because it's closer, right? This is sort of like energy level 3 and energy level 4. Energy level 3 is closer. But the thing is, that room in the skyscraper, it doesn't have to be on the bottom floor. It could be on the top floor. This could be where the available room is. And remember, the skyscraper doesn't have any stairs. So now what you would have to do to get to room number 1 is you'd have to walk to the skyscraper and then walk up about like 4 miles of stairs. That's what you would have to do. Whereas to get to the house, I mean, you have to walk farther, that's true, but there are no stairs you have to climb up. So it's going to be easier for you to get to room number 2 in this case, even though it's farther away. So even though normally the energy level 3 is easier to get to than energy level 4, normally this is true, because energy level 3 is lower energy. Specifically, if we're talking about the highest sublevel of 3 and the lowest sublevel of 4, it might not be the case that it's easier to get to this red one than this green one. So the farther away one in this case, it's actually lower in energy overall when you take into account all the factors. Not just the energy level, but also the sub-level, how much energy that has. So what really happens is this. You think this would fill up, but it doesn't. The fourth energy level's S shape fills up before the third energy level's D shape. So this is where the next electrons go. The next electrons, they also do some cost-benefit calculation, and it turns out for these particular electrons it takes less energy to get to 3D than to 4p. So for these next electrons, they do some sort of cost-benefit thing, and they figure out that going this over 3 up 3, that's easier than getting to the green one, so they go here. The next ones go here. So there's not a simple rule. So how are you supposed to know where the next electrons go in the real world? I mean, if it's not so simple, if it's not just the low energy levels fill, and then the middle ones fill, and then the high ones fill, if you have to do some sort of calculation every single time, how are you supposed to figure it out? And the answer is that you do hardcore quantum mechanics, but you don't have to do that. You don't have to do any hardcore quantum mechanics because scientists have already done it for you. So we know the order that they fill in. And that's nice, because we also put the results in the periodic table. So if you look at the table, you will be able to figure out which one gets filled when. Now, I told you already that these are the S's, the P's, the D's, and the F's. The only thing that you need to get from this whole thing is that the D shape is one level lower than normal. Okay? This is all you really have to know. I just told you the other stuff because I want you to understand it. For example, if you get down five rows, you get the 5s electrons, right? This is where the 5s shapes are. And this is where the 5p shapes are. And that makes sense because you're on row number 5. And you would expect that in between them, which you have the 5d electrons, but you don't. In between them, you do not have the 5d electrons because those d electrons, they fill up weirdly. You have the 4d electrons instead. The 5d electrons are they're one row lower than you would expect. So if you're on row 5, the D shape actually is not at level 5. The D shape is at level 4 right there. Starting through the table, you have the 1s electrons up here, then the 2s, 2p, 3s, 3p, it all makes sense, 4s, it seems good, but it's not the 4d electrons, it's the 3d electrons, because the D shape is always one behind. Then you have the 4p, 5s, and then the 4d, not the 5d, and the 5p, etc., etc. So, which element's electron configuration ends in 4d7? Well, let me show you how to do this. You would go to find the d block, okay, and then the d block is one level lower than it's supposed to be. So, you think 4d is going to be here, right? This is what you think 4d is, but that's not 4d. 4d is one level lower than 4. So one level lower than 4 is the 4d. So even though it's in between the 4s and the 4p, it's the 3d row. The 4d row is one under. So it goes 4s, and then 3d, and then 4p. So the 4s, 4d, and 4p that I have highlighted here, they're not in a straight line. The d block messes it up. Anyway, so this is the 4d row, and then we need to go 7 steps in. So 1, 2, 3, 4, 5, 6, 7. RH is your answer, rhodium. Electron configurations for the d block are annoying. Now I'm just going to go down the whole table and show you all the last configurations to make sure that you get it, because this is my last lecture. This is the 1s shape, 1s1, 1s2, because helium really belongs in that little chink. 2s, that's 2s1 and 2s2. Then we go to the 2p, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Then we go to 3s after that, 1, 2. Then 3p, that's what comes next, and we got 1, 2, 3, 4, 5, 6. 4s, now the s makes sense when you go down 4 rows. So 4s1 is k, 4s2 is ca, but then remember it doesn't go 4d, it goes 3d. So then you have 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then you go to the 4p, it goes back to normal for the p block. 1, 2, 3, 4, 5, 6. Then 5s, 1, 2. 4d, and you got 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is all the 5p's, and to talk about a specific one, you got to tell me it's 5p1, or 2, or 3, or 4, or 5, or 6. And I'll stop now, okay? I think you get the picture. This is electron configurations. I hope this was a helpful set of videos.